In this video, I want us to look at the inverse function of a linear function. Just a quick recap. A linear function is defined by the following equation. Y is equal to ax plus c, or some textbook would say plus q. Still the same thing, where a is the gradient or the slope, c is the y-intercept. But in this video, we are looking at not the linear function itself, but the inverse of a linear function. So let's do that by looking at an example. So say we are given p of x is equal to minus 3 plus 1. This is our linear function that is given to us. So we are asked to find the inverse of this. Remember on our previous video, if you haven't watched it, please go back and watch it. In our previous video, we said to find the inverse of a function, which is the equation of the inverse of a function. What we do first, we express this in terms of x's and y's. All right, so this means we'll turn p of x into y and equate that to our equation. So what we do next is we interchange the variables, which is we interchange x and y, so that we get x is equal to minus 3y plus 1. So after doing that, what we do next is we try to express the equation in terms of x, meaning we make y the subject of the formula, right? So doing that, we get x minus 1 is equal to minus 3y. We divide throughout by a 3, so that we get y is equal to minus 1 over 3x plus 1 over 3. Our p inverse of x is this function. This tells us that we have an inverse function with a slope of, that's our gradient, m gradient of 1 over 3, and our the y-intercept 1 over 3. All right, so applying this in general into the general equation, this will tell you that since the general equation is y is equal to ax plus c, right? So this tells us that in general, the inverse of a function, of a linear function is, let's just derive it. Let me not just write it out for you. Let me derive it for you. Let's derive it together. So this is going to be, we interchange the variables so that we have a y plus c. We make y the subject of the formula. That gives us, divide throughout by a, that leaves us with c over a. So this is the general equation of an inverse of a linear function. So whenever you are asked to determine the general, to determine the inverse, the equation of the inverse of a linear function, this is what you could do. Just identify your a and your c, and then just express it as in 1 over a x minus c over a. So you are done. Just like that. This will save you time in exams and all that. So now let's look at a sketch of this. What does this look like graphically? So what we need to remember now is, how do we plot a graph in general? We are given that p of x is equal to minus 3x plus 1. So the first thing that we need to do is to find the y-intercept. To find the y-intercept, what we need is to let x equal to 0. So we let x equal to 0 so that the p of 0 is equal to minus 3 times a 0 plus 1. So we find that p of 0 is equal to a 1. So that is where our first point is, cuts through 1. So now we need to find the x-intercept. The x-intercept is found by letting y equal to 0. So when we do that, we get minus 3x plus 1. Transpose 1, we get minus 3x. We divide both sides by negative 3. We get x is equal to 1 over 3. 1 over 3 would be somewhere over there. So this means our graph, the original graph, would look something like that. Now let's plot the graph for the inverse, which is p inverse of x, which is equal to, all right, so same procedure to find the y-intercept. What do? We let x equal to 0. So we run p inverse of 0 is equal to 1 negative 1 over 3 times 0 plus 1 over 3. This becomes 0, so we get P inverse of 0 is equal to 1 over 3. So since we have that, this is our y-intercept. So it's somewhere over there. Let's just say somewhere over there. What am I doing? All right, somewhere over there. Okay, now we find the x-intercept. So to find the x-intercept, what we do is we let y equal to 0, so that becomes 0 is equal to minus 1 over 3x plus 1 over 3. Okay, so we transpose 1 over 3, we get negative 1 over 3 is equal to negative 1 over 3x. We multiply throughout by negative 3, so that we get 1 is equal to x. So this is our x-intercept. So this means that our curve runs like this. This right here is our P of x is equal to 3x minus 3x plus 1. And this right here is our P inverse of x is equal to minus 1 over 3x plus 1 over 3. All right, so there is something that I want you to notice here. When we look at the x and y intercept, this is what you should realize. The x-intercept of the original graph, which is this one, the x-intercept of that graph is 1 over 3 to 0. And the y-intercept of that graph again is 0 to 1. But the x-intercept of the inverse of this graph now is 1. That's the coordinate of the x-intercept. While the coordinate of the y-intercept is 0, 1 over. What we have done was just change what was x became y. What was y became x. So that is the whole idea with the inverse of a graph. So you just interchange the variables, meaning you make y equal to x and x equal to y. So the y of the original graph becomes the x of the inverse, while the x of the original graph becomes the y of the inverse. I hope that that is clear. So what you're actually doing is you're simply reflecting that function about the line y is equal to x. So this line here is y is equal to x. That's a straight line, which is a gradient of 1 and a y-intercept of 0. Right, it runs through 0, as you can see. All right, very easy, isn't it? So what you would realize here is, so when you try to find the midpoint between the corresponding coordinates, let's say coordinate A is 1 over 3 to 0, and the inverse of that coordinate would be 0 is 1 over 3. Right, so when you use the midpoint formula and find the midpoint, what you would realize is that the coordinates of the midpoint would be equal, meaning your x would be equal to a y. So you'd have something like this. If your x of the midpoint was 3, then the y would also be 3. That is because you think of it as an idea of a mirror. So like when you look at yourself in the mirror, you see yourself on the other side of the mirror as exactly the distance that you are standing away from the mirror. So that's the idea of an inverse. It's just a reflection about the line y is equal to x. So what you would do if you are given the graph and you are given the coordinates of that graph and you are asked to plot the graph of the inverse of that function that you are given, what you do is just whatever that is x on the original graph, just turn it into a y on the inverse, and then you plot your graph and you are done. All right, thank you so much for watching.